Hello everyone, it's me Gagan Kumar present over here to teach you physics. Let's move on to the video. Today we will be discussing change in momentum. In the last lecture already we completed friction, block over block problems, and today we will be discussing change in momentum, some questions. Okay, so let me go for some concept. After that I'll come to this slide. So here a force is basically what? dp by dt, and this dp is nothing but it is change in momentum, or it is called basically what? Rate of change of momentum. Now here you understand the questions will be how. Let me take directly. So we need to find change in momentum from some picture. So let me take direct question here. So question is like this. So here one wall will be there, and here one perpendicular things are there. Now here one mass is there. Mass is how much? Mass is m. Now here this mass is coming with certain velocity v. Certain velocity how much? V. Making an angle theta with this wall. Making an angle theta with the what? Are you listening or not? Making an angle theta with the wall. Now listen here, then after that what happening? After hitting here, this mass is coming like this. Mass is coming like this with the same velocity v, mass m, going in this direction, making some same angle theta with the wall. That is here coming, here it is. That is coming, here it is going. Okay. Now they will ask what? In this picture they will ask what is your change in momentum? What is your change in momentum? This is your mass, huh? This is your mass. So they'll ask what is your change in momentum? Change in momentum. In this case, you find what is change in momentum. So options will be there here like this. Okay. So here it will be like mv sin theta or 2mv sin theta or mv cos theta or 2mv cos theta. Yes or no? So this type of questions will be there. Now understand here what to do. Now change in momentum. Change in momentum is nothing but what it is. That is final momentum minus initial momentum. So vectorically I am writing final momentum minus initial momentum. Now this is the initial case. This is called condition is what? Final case. Yes or no? Now here what is your initial momentum? Now initial momentum is nothing but, see, first it is coming with mv, right? Like this it is coming actually. Now here if this angle is theta, you do one vertical here. If this angle is theta, then this angle also theta, opposite angle like that. Sorry, what is not opposite? What you call interior alternative angle. Now here what is this? Now this is your v cos theta. What it is, ma? V cos theta. It is in vertically downward, so it is in j direction. So it is minus j direction. And here what is this? Here it is velocity vector reverting, velocity vector. Velocity how much will come? If mass will multiply means it will become momentum. So initial momentum in this direction. Suppose mv I am telling, this mv two component you take. Here it is how much? mv, tell me. mv sin theta. It is in positive I. So initial momentum what I can write? mv sin theta I cap minus mv cos theta how much? J cap. Now final momentum if you want to find, what I can do? What I can do? Final momentum. Now here this is the final momentum. In this direction it will be how much it is? This is your mass into velocity. Mass into velocity. Now do a two component here. So one component in this direction, one component in this direction. Now if this angle is theta, then this angle is also theta. Now this is how much? It is your, एक minute wait. If this angle is theta, If this angle is theta, then this angle is theta, because this is like this one, this type of thing is there, right? Here like this, here like this. If this is theta, then this will be theta. Yes or no? So now here what na, this vertical downward, it will be mb cos theta, and this will be mb sin theta. So it is in minus I and it is in minus j. So final momentum what will write? Now in this direction it is minus mb sin theta I cap minus mb cos theta j cap. Now this one I'll substitute here. Now you substitute and tell what is change in momentum coming. Now final is minus mb sin theta I minus mb sin theta I minus mb cos theta j minus mb cos theta j, then minus mb sin theta I, then plus mb cos theta j. Now check, anything will get cancelled here. So here minus will do the minus mb sin theta I minus minus plus cos theta j. Minus mb cos theta j got to cancel. So how much getting? Minus 2 mb I. So this is your change in momentum, but it is in vector format. But in question there is given in magnitude format. So if the magnitude I will take here, what is the change in momentum magnitude? It is 2 mb sin theta. 2 mb sin theta. So which answer? So answer is second option, 2 mb sin theta. Okay, so this type of things remember. There can be many questions like this. Here it is coming like this and going like this, then what is the change in momentum? Or sometimes they can ask, suppose this is acting, here it is when hitting here, it is hitting for a time t, then what is your average force? What is your average force acting? You can write the change in momentum by time t. So that means you can write here average force, if you want to calculate 2 mb sin theta by how much? T. 2 mb sin theta by t. Now similar type question, understand, this type of question is coming in exam. Remember, if average force they ask, then what? Change in momentum by time. Okay, because we know change in momentum is what? Change in momentum by time is nothing but force. So force equal to change in momentum by time. Yes or no? Write down. Now one more question you try, similar type. Now listen ma, here suppose I am telling here the same mass m, it is coming and hitting and going like this, yes or no? Same mass m, it is coming with velocity how much? V. Here also velocity V. Now this angle is theta, this angle is theta. Now what is the change in momentum? The change in momentum, the change in momentum is how much? See, just previously we did this angle, right? This angle how much? Theta we take, but now it is what? 90 minus theta. So the previous answer how much it came? Previous answer similar type, it came 2 mb sin theta, because this angle is theta. Now in place of this, if I'll put how much? 90 minus theta, how much it will become? Sin 90 minus theta is cos theta. Sin 90 minus theta is, the answer is what? 2 mb cos theta. So no need to calculate any other thing. Yes or no? So you don't need to find initial momentum, final momentum. Just remember, if theta is this angle is mentioned, then it is 2 mb cos theta. If this angle is mentioned, then this will be 2 mb sin theta. Okay. So here 2 mb sin theta, but this angle is, if you are considering this one, it is 90 minus theta coming actually. If this theta means this is 90 degree. Okay, 90 minus theta, that's why it is 2 mb cos theta. Remember this directly. Okay. So remember picture. If this angle mentioned here theta, okay, this with this theta mentioned, then it 2 mb cos theta. But with the wall, if they mentioned, with the wall they mentioned this theta, then it is 2 mb sin theta. Similarly, here suppose average force they ask, they'll give time and average force. Average force is change in momentum by time, or 2 mb cos theta by time t. T will be given, mass will be given, velocity will be given. Velocity is 10, mass is 1 kg. You can find easily. Okay. But remember here, same velocity coming, same velocity it is going. Yes or no? Clear idea? Okay. Now listen, another type. Another type is, here this wall is there. Now one object is coming and hitting normally. So this is coming with velocity v, mass m, and hitting here, again going back normally with velocity v. Same velocity it is going. So what it is? Hitting normally. Hitting normally, it is hitting. Normally hitting and going. So here if I want to ask what is change in momentum, what will be change in momentum? Now listen here. Now here if this is coming like this way, means from this side if we check, from this side like this if we check, how much angle this is? This total 90 degree angle. So here that means theta become 90. If theta become 90, so 2 mb sin theta, so sin 90 is 1. So directly let me write it is 2 mb. So change in momentum how much? 2 mb. If options are given also, okay, suppose options are given like this. Let me write here. Options are given 2 mb, mb, okay, 3 by 2 mb or 0. And what is the change in momentum? Change in momentum will be 2 mb. Okay, or you can tell also this is the initial condition, this is the final condition. Okay, for this masses. Now what you calculate here. What is your initial momentum? Now mass times velocity in positive direction means plus I, and final momentum is what? Mass times velocity. Mass times velocity. Okay, but it is in minus I direction. So right, it is minus I. Now change in momentum vector is how much? P final minus P initial vector. So it is your mv minus I minus mv I. Now how much it is coming? 2 mv minus 2 mv I. So this is your change in momentum, but it is in vector format. Remember, change in momentum in vector format. Okay, so it is coming how much? That is your 2 mv I cap, minus is there, remember minus will be there, but here if you magnitude wise take it, then it will come as 2 mv. Okay, so final minus initial you can do. So remember, this type of questions mostly they are asking. So change in momentum calculation from the picture. If a picture is given like this, then what is your change in momentum? Your change in momentum is 2 mv. Okay, actually vector wise it is minus 2 mv I, but here it is magnitude wise it is 2 mv. Okay, so this much remember. So this is normally hitting. Normally hitting means this ball is coming here and hitting, going and hitting and coming back, but here making some angle with the wall. Okay, but you be careful, this angle is given means this angle you know means it is 2 mb sin theta. If this angle you know means this is 2 mb cos theta. Okay, so that one you can do. Okay, this angle is taken from here it is taken. Okay, so from this line, dotted line, this dotted line is given. From the dotted line below and above they have taken angle. Okay, and here the angle is taken from what? Now from the wall it is taken, from the wall. From wall angle is taken, here theta, here theta. Okay, so change in momentum you are able to calculate. Now sometimes what they will ask here, now they will give here some questions like with angle. Now here dotted line is there. Now this angle is given 30 degree. This angle is given how much? 30 degree. Now this mass going with the velocity, final the total velocity how much given? Here it is 10 meter by second, and here mass is 1 kg. Here also mass equal to how much? 1 kg. Okay, the same mass, it is coming with 10 meter per second. Now here 30 degree angle, here also given it is 30 degree angle. Now what you need to find? You need to find the change in momentum. The change in momentum. The change in momentum you have to find. Okay, so options are given here. So here write this 10 Newton into second or 20 Newton into second or 5 Newton into second or 0. Just write, just 0. So try to understand here. Okay, now understand here. So here 30 degree angle, this theta is 30 degree and this theta is given. So change in momentum is nothing but here 2 mv sin 30. So 2 mv sin 30 is half of cancel, so it is mv only. So if you change in momentum mv only, then what you can do here? Now here m value is given 1, v value is 10. So it is 10 kg into meter by second, or you can tell this one as what? 10 Newton into second, because change in momentum unit is Newton into second. So how much coming it is? 10 Newton into second. Okay. So this type of questions will be there. Now we'll discuss another type of questions, how other type of questions will ask. Okay, from the graphs. Now come to here. Now suppose you want to find change in momentum. So your force equal to what? Now change in momentum by time. Okay, or change in time basically. And here that is also called basically rate of change of momentum. if P is given function of T, P is a function of T, then force equal to what? Now dP by dt you can calculate from this relation. Okay, dP by dt is nothing but how much? That is your force equal to F. Okay. Now here if dP will take this side, F dt will take, then here what? The integration of F dt is nothing but that is also change in momentum, and that is also called as what? Impulse. Okay, remember change in momentum is also called impulse, or impulse is what? For small interval of time a large force is acting, and this is called impulse. That impulse is also change in momentum unity or dimension is equal to impulse unity. Okay, momentum change in momentum or momentum unity equal to what? Impulse unity, or dimension is equal to impulse dimension. Now here what is this change in momentum? Mass into final velocity minus initial velocity, or mass into final velocity v minus initial velocity u. Okay, like that also you can tell. So change in momentum is integration of F dt, change in momentum also impulse, change in momentum also mass into final velocity minus initial velocity, or v minus u. And remember, if your change in momentum is integration of F dt, that means here if F and T graph is given, suppose remember like this, F and T graph is given, then area under F and T graph will give you what? Will give you change in momentum. So whatever graph is here, suppose whatever graph is like this graph is there. Now this area you find, this area and this area. Okay, and this area will be A1 will be suppose positive area, and here A2 will be what? Negative area. So below time axis whatever area will come, that area will be negative. Above time axis whatever area will come, that will be positive. So area under FT graph, above time axis area is positive, below time axis area is negative. So that one also remember. So for example, area, just understand here. So this type of picture is there, means this is called a trapezium. Your height is how much? Height is h. Height is h. Here this side is A, and this side is how much? This side is B. So this side is B. Now here what is this area of this system total triangle? This trapezium. Height is h. Remember this height is given how much? Height is h. It is half A plus B into h. Half A plus B into h. And similarly, if a triangle area you want to find, for a triangle area, suppose a triangle is there, then height will be h, and h will be there, and base will be B, and triangle area is how much? Half into base into height. And if a rectangle is there, then rectangle area is how much? Now length into breadth. If length is there, length is L, and breadth is B, and length into breadth is nothing but a rectangle area. Okay, so remember, and based on this one question is there, the same question I am writing again. Just try to understand here. Okay, so what I am telling here, like if this type of picture is there, this is also a trapezium. This is also a trapezium. Here this side is A. This is to our parallel side. Parallel side. This height is how much? Height is h. Now if I want to find area of this triangle, this trapezium, how much it is? Half into parallel side addition into height h. Okay, so half into A plus B into height h. Now suppose a triangle is given like this, or triangle is like this. Now just you find h. This is the height h. This is the base B. This is the height h. This is the base B. Now what is the triangle area? Now triangle area equal to half base into height. Here also same thing. Half base into height, triangle area. This is the trapezium area, triangle. This is the triangle. This type of picture is trapezium. It will be like this, or it can be like this also. Same. All are same. Here it is height h. Here it is A. Here it is B. So half into A plus B into h. Okay. So these are trapezium formula. Okay. Or sometimes like this also graph will be given. Okay. Sometimes graph is like this. Suppose this also you understand. This is also same. So this will be your A. This is also looking like trapezium. This is your B, and this is nothing but h. Okay, A plus B, h. Okay. Now here, this is trapezium, and if rectangle is understanding, rectangle is what? Rectangle is L. This is your B, length and breadth. So here area if you want to find, this area is nothing but L into B. Okay. Now based on this, you understand this question. So here the question is like this. Question is, here you have a picture like this, Uh, okay, so it is 0 second. This is your time axis. This is the 1 second, and here it is 2 second. Here it is 4 second. How much given it is? 4 second. Now here this is given 6, and here it is force. This is taken in Newton. This time is taken in second. Time is taken in second. So this type of force and time graph will be given. Okay. Now here what they'll ask? They'll ask for what is your change in momentum. The change in momentum from the graph. Change in momentum from the graph you have to find. The change in momentum is how much? Option A, I'm telling 5 Newton into second. Option B, 10 Newton into second. Option C, okay, 15 Newton into second. And option D, 0. Option D, 0 you take. Okay, that much you take. No worries, we'll see. So now listen. So what change in momentum? I told if you want to find change in momentum, then what you take? Now you have to take above time axis. Above time axis area is what? Above time axis area is positive. Area is what? Area is positive. And below time axis? Below time axis area is what? Area will be negative. Above time axis area is positive. Below time axis area is negative. Now here this area you consider. This area you consider. Now this is your above time axis, and this height is how much? 6. And here this is how much? This is your 1 second, and this is your 2 second. So here 1, here 2, like that it is there. So these two are parallel side. So this is looking like a trapezium. If this area I want to find, A equal to how much? Half into add the parallel sides into height h 6. And area is how much coming? A1 take. So this A1 is coming on 9. A1 is coming how much? 9. Because 1 plus 2 is 3, and you cancel 2, 6 is 3. Okay, so how much coming area? Area is coming 9. So here it is coming 9. Or you can find also this area you can find. So it is like this actually picture is there. So you can understand this is a triangle and this is a rectangle. So triangle area plus rectangle area also you can find. But here I told already. This is the trapezium actually. For trapezium, what if two parallel sides, you know, these two are parallel side. Okay, this parallel side, this and this. Then what will happen? Now area will be half parallel side addition into height. So that one I am applying here. Okay. Now here see the below axis is basically it is your negative area. So why it is negative area? Because I told you here one value also take. Here value is not given. You take here it is -2. So force is basically -2. Now here if this height will check or this distance will check, it is 2, and this distance is also 2. So 2 into 2 how much? Now for this area A2 how much will come? Remember this in this axis I have to given it is -2 Newton. So that's why this distance is 2. 2 to 4 difference is 2, and here it is 0 to -2, the difference will be 2. So 2 into 2 4, and below time axis is negative area. So 2 into 2 4. So it will be -4. A2 is nothing but -4. So A2 area is negative, A1 area is positive. Now what we can do? Now here if you want to find the total area, that is nothing but change in momentum. So change in momentum basically total area, which is A1 plus A2, and A1 you got 9 and A2 is 4. So -4 basically. So how much it is coming? Now 5. So change in momentum is 5 Newton into second. Change in momentum is 5 Newton into second. Remember here below axis also they should give this mention. This is your -2. So this reference is -2, and this reference is 6. And remember this dotted line. This dotted line is just for reference. It is not the exact graph, like solid line, not solid line. So it is not a graph. It is just a reference. So above it is 6. It is -2. Now easily you can find it out. So everything will be given. So you can find it out, so no need to worry. So your area you can find, then after that area will give you change in momentum. Area will give you change in momentum. Okay, now recent one previous year question we will try to do. I just try to understand that. Now here let's take me one slide here. Just take here NEET question here. What they gave. Now here one diagram is given, y-axis, x-axis. So force and time. Force and time is given. Here it is y-axis is force and x-axis is time. And a graph is given like this. Graph is given like this. Okay. Consider a graph. Now here, this is your 0, and this reference I am giving in yellow color. So this reference is given as +3, and this is your +6, and this is your -3. It is 2 seconds, it is 4 seconds or 6 seconds, like that it taken. Here 8 seconds, something like that it is taken. Okay. So right here it is 2, 4 and 8. Okay. So this T is in second, and the force is in Newton. Now they're asking the change in momentum in this case. Change in momentum in the graph. Change in momentum is how much? Option A, option B, option C, option D. It is given like this. Okay. So what you do? So here you have to find positive area. Above time axis is positive area, below time axis is negative area. So you try to find yourself. The options are given 24, 20, 12, 6. 24 or 24 Newton into second, 12 Newton into second, 6 Newton into second, 20 Newton into second. Okay. So try to calculate yourself. Positive area, negative area, positive area, then add every area. Okay, add all area, you'll get your answer. Okay. Now listen here. So here, if this area I'll check, it is a triangle actually. This area equal to A1. So how much it is? Half into base. So this is the base actually, 2. Height how much? This is the height actually, it is 6. So 2 into 6. So it is coming 6. So it is a positive 6. Now this is the negative area. So this is below time axis. So this area will check, it is A2. That is how much? Now this distance is basically 3, and this distance is basically 2, because 2 and 4 difference is 2. So 2 into 3, which is 6 basically, but it is minus will come. Area 2 is minus because it's below time axis. And here if you check, this distance is 4, this distance is 3, and total area if you check A3, it is plus 12 will come. Okay, 3 into 4 is 12 because it is a rectangle type. It is a rectangle type, but it is a triangle. So now if you add all area, that is your change in momentum. Okay, that is your A1 plus A2 plus A3. So A1 is 6, A2 is minus 6, A3 is plus 12. So it is coming 12 Newton into second. So change in momentum how much? Total area which is change in momentum is 12 Newton into second. But remember here they'll ask according to time also. So here they're asking basically change in momentum how much? Now for this total graph, okay, at the end of what 8 second, or at 8 second basically you can tell. So full time you are taking, but sometimes according to time also they can ask. If they ask up to 2 seconds, then change in momentum is only fast area A1. Up to 4 seconds, then A1 plus A2 area you have to take. Okay, although it is minus is there, so 0 momentum. But again, if they are asking up to what 8 seconds, then after this total area you have to calculate. So you need to take care about also time little. Okay. So I hope you understand. So simply you need to calculate area, positive area, negative area, then add the area, then you'll get what? Change in momentum. Okay. So here this type of question is mostly asking. So it is also a previous year question. So it is asked in 2014 they asked here. I hope you understand. And thanks for watching. Like and subscribe Vidhyalakshmi NEET Academy YouTube channel. All the very best. Thank you all.